Okay, so we're doing two different kinds of factoring. We're going to start with common factoring. It should be kind of familiar. Once we've done a few examples, you should be able to follow along fairly easily. The factor by grouping is a little bit wonkier, but don't worry, you'll get there eventually. Okay, common factoring is easy, it's simple, but it's a big deal. So you really need to know how to do that. Factor by grouping, something we start chipping away at now, but you won't really need to do it till like grade 12. Like it won't come up a lot until then. So we just see it a little bit in grade 10. If I had a question like this, 3x squared y times that trinomial, what would I do? Well, I would multiply this through by each of those things, wouldn't I? And it would look like this. 3 times 2 is 6. X squared times x. Add the exponents. 2 plus 1 is 3, so x to the 3. And then y times the 2x doesn't have a y, so it's just y. 3x squared y times 5y, so 3 times 5 is 15. X squared, the 5y has no x term, so it just stays x squared. And y times y, add the exponents. 1 and 1 is 2, so y squared. Y times y is y squared. Last one, 3xy squared times 3 is plus 9, and there is no variable part, so it just stays the same. Right? You remember this? You did this in grade 9 for sure? You should have, yeah. You do distributive property, and you multiply variables and that kind of thing. Okay, so that should be, and we did stuff like this the last few days. But distributive property, right? Okay, so before we connect this to what we're doing today, we're going to talk a little bit fundamentally about like math and math class. So when you first learn something, like in grade 1 you learn how to add, okay? And then you learn the opposite thing, which is subtracting. So if I add 5 and then subtract 5, I end up back where I was, because those are opposite operations. Does that make sense? Right? So you go 5 plus 3 equals 8, and you think 8 is your answer. But it turns out, maybe 8's not your answer. Maybe instead you do 8 minus 3 and get back your 5 from the beginning. Does that make sense, kind of? Okay, so my point is, let's say in grade 9, when you were doing distributive property questions, you thought this was your answer, like to all questions. People think math is all about getting an answer. And so if I give you two numbers, you add them together and that's your answer. Or if I give you a statement like that, you multiply through and that's your answer. But it's not that simple. Math isn't about questions that are presented and you just work away at them until you get the answer. Like that's, like in math class it is, because we're practicing skills. But real math, that's not really what we're doing, okay? And so it's about the skill that we're learning. So in grade 9, you get this as your question, and you expand it. This is called expanding. Okay? And then that is your answer. But in grade 10, we're going to do the opposite. Just like you learn to add, then you learn to subtract. And so in grade 10, I'm going to give you this, and that's going to be your answer. We're working backwards. Right? See where I'm going with this? And some people get confused about that. So they think that this is just always the answer, because that's what you learn first. But be careful with that, okay? If you're asked to expand, good. That's what you're supposed to do. But if you're asked to factor, that's not your answer. That's the question. That can be confusing, but it's a matter of we're learning skills. Sometimes I want it to look one way. Sometimes I want it to look another way. There's no universal truth that everything should look a certain way, or that every math question has an answer like 10. Doesn't work that way. Okay, so that's what factoring is. Factoring is going the opposite way. So how do I do that? Well, the first thing I'm going to do is I have to figure out this part. I have to figure out what that is. And so when we learn to factor, we always, I think it helps, compare it to its opposite operation, which is distributive property in this case. So when we start factoring down here, we're going to think about how it's the opposite of this. And they're working backwards from each other. So if I gave you that, how would you use it to come up with that? The thing that you would multiply by. And then, how do you come up with what's left in the brackets? And the trick about factoring is, which can be difficult, is there's no like algorithm for it, right? There's no like step 1, step 2, step 3, step 4, you're done. It's like you kind of look at it, you do some thinking, you do some problem solving, you make some connections, you write down the answer.
Aren't there like, I'm not infinite amount of answers, but aren't there a lot? Because like over here, you're just, let's say, you basically divided by 3 x to y, and then you put it around there.
Yeah.
So can you do that more ways than one?
Kind of. But when we factor in this class, we're going to always try to factor it as much as possible to the lowest amount, so it's as fully factored as it can be. So there's only one answer to that. And again, it's just a skill. So like in some situations, what you're saying is absolutely true, but for us, we are working towards an answer. Okay, so let's take a look at what this means. What does GCF stand for? Who remembers that? This is something you should have talked about last year and the year before. Riley? Very nice, greatest common factor. So you've probably done greatest common factors of numbers. But we have to find the greatest common factor between all 3 of these terms. We take that, we write it out front. That's going to be our this thing. And then we figure out what's left in the brackets. Okay, so let's try to follow. This first one's a little bit wonky. It's demonstrating a whole bunch of stuff. A lot of the ones you're going to see throughout this unit are going to be simpler. But it's a nice idea to really get an understanding of what's going on here to look at some more complicated questions. Okay, but like this one, for example, it's like a made-up math class question. You never see something like that in real life. Whereas a lot of the stuff we do, like starting tomorrow and after that, you do see those in real life. Okay, so what number is the greatest common factor of each of the coefficients? I'm looking at 4, 32, and 18. So I'm asking for a number that divides into all 3 of those things. Sometimes there's lots of them, and you have to pick the biggest. Sometimes there's only one, and so you just go with it. 1 is never the answer. Like if 1's the answer, then you're done. You don't do it, right? But if there's something bigger than 1 that goes into all of those numbers, 4, 32, and 18, then we're going to factor it out. Riley, what do you think it is? Does 4 go into 4? Yes. Does 4 go into 32? Yes. Does 4 go into 18? It doesn't. So 4 looks like the right answer. And sometimes that's what, like, this is what I'm saying, is there's no, like, you just kind of have to think. 4 jumps out at you because it goes into the first 2 things. But you got to check it doesn't go into 18, so not quite.
I think it's 2.
2. Does 2 go into 4? Yes. Does 2 go into 32? Yes. Does 2 go into 18? Yes. So you're right, it's 2. Okay, now here's a bit of a trickier part. I have to look at each of the variables individually. So I'm going to start with the a's. What divides into a squared, a, and a? Like, what's the biggest a that I can pull out? The biggest number I can pull out was a 2. What's the biggest a part that I can pull out? What will divide into all of those? And all you do is look at the exponents and take whichever one's smallest. Because you want to take out as big as possible, but you have to take it out from each one. So whichever one's smallest, that's what you do. So what do you think? A to the 1. But so we say A, not like 1. Yeah, good. So A. We'll do some other, we'll see some other examples where it gets a bit more interesting. Actually, the B's are a bit more interesting. So I have B to the 5, B to the 2, B to the 3. Which one's the smallest? Yeah, so I take out B squared. Because I can take that out of B to the 5, I can take it out of B to the 3, and I can take it out of B squared. But I can't take anything bigger. Right? Okay, what about the C's? C cubed, C to the 4, C squared. Jaden? C squared. That's my GCF. When you're common factoring, you have to find your GCF. You have to think about every part individually. You look at the coefficients first. Then you look at the variables like A, and then if there's more variables, look at them, B, and then if there's more variables, look at them, C. And then you write down your GCF, and then you write down a bracket, and then we're going to figure out what goes inside the bracket. Liam? Right. And if you think about what exponents mean, it makes sense as to why. But I don't think we need to go over that right now. I can show you the example later if you want to see what I'm talking about.
So probably you just find the lowest one and then you
Smallest exponent, yep. Okay, so now how do I figure out what's left? I started with the trinomial. Remember, I'm doing the opposite of this. So I took a thing here, right? And I multiplied it through by 1, 2, 3 things, so I got 1, 2, 3 things at the end. So when I take this out, I gotta have 1, 2, 3 things inside, because if I was multiplying, I'd have to get back these 1, 2, 3 things again. Does it see the connection? So how do I know what should go here? I'm thinking to myself that this times this has to give me that, because it's the opposite of the distributive property. So that means I'm dividing. So 4 divided by 2, 2. A squared divided by A. How do you do that? Yeah. The other way of thinking about it is you subtract the exponents. So b to the 5 divided by b squared would be what? B cubed. That should be familiar from last year. I haven't done it in a while, but you should have done that. And then c cubed divided by c squared is c. And don't forget, you can look at these two things and they have to multiply together to give you this. So c squared times c is c cubed. So that works. That makes sense. Yes?
So where did we get the 2ab squared?
2ab squared c squared? That was the greatest common factor. So we looked at all three of these terms to find out what was common between them.
So we just collect the greatest common factor out of all of them?
Kind of, yeah. We'll take another look at, we'll do some more examples after and it'll hopefully make sense.
The number inside the bracket, you just divide the numbers on top and the number on top.
Yeah, the GCF, exactly. You're just dividing. So so let's watch again. Negative 32 divided by 2, negative 16. What's a divided by a? 1. So it's just gone. Don't write it, it's gone. What's b squared divided by b squared? 1. Anything divided by itself is 1, so it's just gone. What's c to the 4th divided by c squared? So this is negative 16c squared. See how this works? 18 divided by 2 is 9. A divided by a gone. B cubed divided by b squared is b. C squared divided by c squared is 1. It's gone, so bam, I'm done. So some people, what they want to do when they get here, they go, oh, look, this is a distributive property question. I know how to solve this, and they expand it. That's not what you're supposed to be doing, though. You're supposed to be factoring here. So this is my answer. Because that's factored. So if you expand it, that's wrong. That's not what you're supposed to do. See what I mean about, like, what's a question, what's an answer? It depends. There's no universal truth to what an answer looks like. Depends on the question. Put your pencil down. Don't copy this down, just watch. You can check all of these and see if they're right, okay? But don't do it on a test. Do it on a scrap piece of paper if you want, or do it in your head. Don't go equals and then write it out, because I'm going to say, sorry, that's wrong. Because that's not, you re-expand it, that's not the answer. But you can do it to check. 2 times 2 is 4. A times A is A squared. B squared times B cubed is B to the 5. C squared times C is C cubed. What does that look like? That. Okay, 2 times negative 16 is negative 32. A, b squared, c to the fourth. Right? I'm multiplying those two. Now I'll multiply these two. And that's plus 18ab cubed c. Is that, c squared, sorry. Is that the same thing as what I got up here? Yes, it is. Check, my answer's right. Right, I can check my answer. But don't do it in the question. Because then it looks like you think this is the answer, and it's not. So I'm going to get rid of it. Okay, so let's try. This one's a lot simpler. That was like a complicated question that has all kinds of stuff going on. Now let's take a look at a bit of a simpler one. And work up from there. So the first thing you're doing, you can try this on your own if you like. First thing you're doing is trying to find the GCF. Look at the coefficients first, then look at any variables that the terms might have in common. So if you're not too sure, that's okay. We're going to do it together. So I look at the coefficients first. What's common between, what's like a common factor that can be, this is what means to be divided out of, both 2 and 10. What's common to both of them, Megan? 2. How many terms do I have? I have 2 terms, right? 2a squared and negative 10. Those are my 2 terms. 2 is common between both of them. Is there any variable in both of them?
But what if 10 doesn't have a variable, so that's not common, so if you times it, wouldn't you?
No. So can I pull a variable out? No. No, because it's not common between the two. What you're saying is exactly right. 10 doesn't have an a in it. So it's not common between the 2 terms. So that's it, I'm done. That's the GCF. Yep.
If you actually say, since you're taking away 2 from that 2, does that 2 just disappear? Where does it go?
What's 2 divided by 2?
1.
1. So this is 1a squared. What's negative 10 divided by 2, Alan?
5.
So negative 5, right? And that's the answer. 2 times a squared minus 5. If I'm not going to do it, because that would be wrong, but in my head I can redistribute the 2 and see that I get back the original answer. The question, sorry. Is everybody okay? Following along okay? Okay, let's try B. What's different about B? The 10 has an A in it. See if you can find the GCF while I answer the phone. Okay, so what's the GCF? Anang? This time it's 2a. See the difference between A and B. In B, they both have at least one A, so I can take that out common. A to the 1, that's the most you can do. And it's a 2 and a negative 10 in both cases, so I can take out a 2. Good? So how does that affect my answer when I divide through? 2 divided by 2 is 1. A squared divided by A is A. Negative 10 divided by 2 is negative 5. And A divided by A is 1, so done. Okay, try C. Just try to get the GCF. And then if you think you can divide, you can try that too, but at least try to get the GCF. Okay, so I hope you got something written down. Just think about this for a minute, though. Don't tell me the biggest, necessarily, but somebody tell me something that's common between 12 and 18.
A common factor of 3.
3. Do you agree? I can divide 3 into 12 and 3 into 18? Agree, good. What's another one? 2. Do you agree that both 2 and 18 can divide? 2 can divide into both those? Yeah. Any other numbers? 6. Do you think 6 goes into 12? 6 go into 18? Yeah. Is there anything else? I think that's it. So we have 3 options. Which one do we take the biggest one? Right? And if you don't take the biggest one, you'll get an answer, but it won't be factored fully. I'm going to show you that in a minute. We're going to start with the 6 because that's the right answer. So if you had 2 or 3, that's okay. Just below, write the correct answer, and you can compare the 2. Now, what about the variable parts? Alan?
X and Y 3.
Nice. And then bracket. 12 divided by 6 is 2. X squared divided by x is x. Y cubed divided by y cubed is 1. Gone. 18 divided by 6 is 3. X divided by x gone. Y to the 4th divided by y cubed. 4 minus 3 is 1, so that's y to the 1. Done. Put your pencil down. Don't copy this down. Don't copy this down. Don't copy this down. What if I only took out a 3? But I got the rest right. X, y cubed. So that would be 4x plus 6y. And what do you notice about what's left in the brackets there? And then, yeah, good. What else? Well, you kind of saying the same thing, but in a different way. There's still a common factor in here. 4 and 6 still have a common factor of 2, don't they? So when you factor, look at what you have here. If there's anything left inside, your GCF wasn't big enough, what I would do is scratch it out and try again. Look for a bigger number. Your variables are probably okay. Although if I had an x and an x in each of these, I'd be like, oh, I still have x's left in all of the terms. Or I still have y's left in all the terms. My GCF was wrong. So you'd have to go back to the beginning and do it again. You could, there is a way like to try to do a second step, but it's messy. It's not a good idea. So the best thing is to just kind of scratch out what you have or erase what you have and try to find the GCF from the beginning. Okay, let's try another one. Same thing, try to find the GCF. So what's the common number? Okay. 4. 4 goes into 12? Yep. 4 goes into 16? Yep. 4 goes into 4? Yep. Nothing's going to be bigger because the 4 obviously can't have a bigger factor. Good. What else? Is there an a in each? Yes. What's the smallest? Just a to the 1. Is there a b in each? Yes. What's the smallest? Just b to the 1. I bet a lot of people had a c written in there as well. But there's no c in the middle term. So you can't factor out a c because it's not in everything. So 4ab is your GCF. Is that okay? So you got to look for that. That's like an easy mistake to make. Be careful of that. 12 divided by 4, 3. A squared divided by A. B squared divided by B, B. And then C cubed, that part doesn't change because there's no C. Yes, Liam? You sure? Plus 16 divided by 4, 4. A to the 4th divided by A cubed. B squared divided by B, B. 4 divided by 4, 1, so minus 1. The A's are gone, the B's are gone, C, so get rid of that 1 actually, so just minus C. These ones with all the numbers and like all the variables and all the exponents are just questions so that we get to thinking about what a common factor is. They're not the kind, like they don't show up naturally. E and F are a bit more normal kind of questions. You'll see what I mean in a few days. But like the question like D really does make sure that you understand common factoring in general. So it's a good question for that reason. Yes? Are you sure? Okay, so let's try E. It's probably a little bit easier. So I can pull out a 2 of each of those. Does every term have an x in it? No, only 2 of them. So just 2. 2 divided by 2 is 1, so that's just x squared. 14 divided by 2 is 7, so that's 7x. 24 divided by 2 is 12. And again, look, if I multiply back through, 2 times x squared, 2 times 7x, 2 times 12 would give me back that. Okay, last one, F. Give it a try. So I bet you a lot of people thought, well, 3 goes into 3 and 3 goes into 12, but I don't know if 3 goes into 96. So what do you do? Yeah, use your calculator and check. Good guess. You're probably right about 3, but you have to check it in everything because it's got to go into everything. Turns out it works, so let's take out the 3. Do you see any variables in common between all 3 terms? Rachel, do you see any variable? A. What about x? No, because there's no x in that last term. So that means I'm done. Okay, and I'm left with x squared minus 4x minus 32, I believe. Common factored. Any questions about common factoring? How many people feel okay about common factoring? Okay, remember this. Remember that you feel okay with this, because I'm going to show you factor by grouping too, but it's a bit strange. So if you feel like, whoa, afterwards, like, I don't understand, common factoring is a really important one, and you do understand that. And factor by grouping is actually not that hard, it's just a little weird. Okay, so practice factor by grouping a little bit, and you can get it. It's not that bad. It's just, it's very specific, it's very different. What do you notice about this first example? Z, what do you notice? Yes, good. It's got 2 distributive property questions in it. That's true. What else? The brackets are the same. X minus 2 and x minus 2. That is key to factor by grouping. They have to be the same. So this one's set. This is like a question that's halfway done already. So this is an easy kind. Okay, just to show us what this has to look like. So you have to have two brackets the same. So what I do is I write that bracket first. And this is, believe it or not, kind of like a common factoring question. So I common factored that out. And then how do I write what's left? I just write 3x and plus 4. And I'm left with two binomials multiplied together. Done. Don't expand it. That's what we were doing the last couple of days. That's not what we're doing here. We're factoring, not expanding. So this is finished. Check, finished. Easy enough, right? The question is, when I'm given something like this, how do I get to that step? Yes, Liam?
How did you get that answer?
I took the bracket that is repeated, x minus 2 and x minus 2. It has to be like that. If the brackets weren't the same, then you can't do it. Okay? I wrote that out front. See that? And then in the second set of brackets, I wrote that and that. That's not hard, right? You might be wondering, but why? Don't worry too much about it right now. Just try to remember that that's what you do. So how do I get to that step? Okay, so just watch for a minute. It's not obvious. Part of the problem is this isn't as obvious. It's not as easy to make a connection to as the other ones. Okay, but watch me for a minute. When I have four terms like this, and all the questions you have to do are called factor by grouping, you know that they're factor by grouping, so you just do it the same way. I take the first two, and I common factor them. What's the common factor? 3x. Is that true, Megan? Okay, good. Yes, it is true. Yeah. Just want to make sure you guys agree. Divide it out. I'm left with x minus 2. Now I factor the second 2. Common factor them. What's common between the second two? Plus 2. And when I divide it out, what do I get? Oh, look, x minus 2. Like I said, that has to happen. If that didn't happen, the question, you either made a mistake or the question isn't a factor by grouping question.
Can there be more than 4 terms?
Of course it's possible, but there won't be for us. We're just looking at these simple kind, but you could develop a question where it was like that. Yeah, Jaden.
What's better about factoring by grouping instead of just doing
It's not really such thing as normal. Different kinds of questions need to be factored in different ways. Tomorrow we're going to look at factoring something totally different. This question can't be factored as a common factor question. Like there's nothing in common between all four of those terms, right? So this is the only way to factor it. Yes.
do factor by grouping when what's called you can't do two things? Like how do you know if they switch your factoring?
We'll talk for today. The question will say factor by grouping. So that's how you know how to factor by grouping. Down the road, after we've looked at all different kinds of factoring, we're going to talk about how you know when to do which one. But part of it is an art. You just get better at it and you just start to see the patterns and you just kind of know. Okay, so how do I finish this one off? X minus 2, I write that, and then I write what's left, right? 3x plus 2. Okay. These ones are really tricky. Yes, Ziggy.
If you had like a longer question, how would you know if you split it off?
You wouldn't. Although I'm going to answer your question in a different way with this next example. So this next example isn't really set up where I can factor the first two and then factor the second two. It won't really work the same way. So I have to rearrange. How do you know how to rearrange? There's no rule to this. It's an art. You have to understand the process. You have to think about it. But when I see 14 and 7 and I see that they have something in common, I'm going to write them side by side. So 7a squared plus 14a. Because I know I can pull a big common factor out of those two. And then I'm going to write minus 4a minus 8. So I'm kind of writing them in order. Common factor, the first two. Common factor, the second two. I want it to look like a plus 2. What do I divide out to get a plus 2? Tony? Negative 4. How do you know when to factor out a negative and when not to factor out a negative? You have to think about these brackets being exactly the same. You have to make sure they match. I'm going to repeat this one more time. Factor by grouping is a little bit strange. It's fair if you feel that way, and if you feel a little bit like, I don't know if I'm fully following that, that's okay. There's a bunch of questions to practice. You should really try some of them, even if you feel a little confused. Go back and look at the lesson. Watch the first couple of examples in the video if you need to, but give it a try. But we'll chip away at it a little bit, and by like next week, then you should be getting it better by then. Okay. Factor by grouping it's a bit of an oddball thing, but like I said, something that we should start thinking about now. Then it'll be easier when we get there. But common factoring is like super important. You got to be good at common factoring. Riley, you had your hand up.
What if like you can't get the two sets of brackets to be the same?
Yeah, then it's not factorable. Then you either have to rearrange, which won't happen too often, or like it's not set up. Like if you tried to make your own question, probably wouldn't work. Factoring is really special. You can make your own distributive property question. That'll always work. You can't make up your own factoring questions. They have to be set up in a way so that they will factor. So it might be, now factor by grouping, I'll never give you one that's not factorable. They'll always work. But for example, if you made up your own, then it just might not be factorable. That's a thing. Good question. Okay, we're going to try 3 here. Try the first one. It's a factor by grouping question. Give it a try. It's got a little bit of a trick to it, but give it a try. I'll get you started. You common factor the first 2 terms and common factor the second 2 so that you have the same brackets, right? So give that a try. So what's common in the first 2? Riley?
5x.
Okay, nice. How many people got that? 5x. And what's left? Tatum? X plus 1. Now take a look. This is the twist. Take a look at that second part. It's already x plus 1. So this is just like plus. It's already x plus 1. There is no common factor, but it's already the same. So Ziggy, what do you think my next line would look like? What's the first part to this? Yeah, I just write down that bracket that's repeated. So the question is, what do I write in the second bracket? Tara, what do you think? 5x. Good guess. Right. Plus 1. Because it's like 1 times x plus 1. That can be a little bit weird for some people. Take a look at B. All the factor by grouping questions we did, how many terms do they have? 4, because you common factor 2 and common factor 2. It's got to have 4. Does B have 4 terms? No. It's not a factor by grouping question. What kind of question is B? Common factor. So try B. It's a common factor question. Go ahead, try it. Megan, yes?
You only divide x plus 1, is that just because a you left start x, or is it
Because that's like a 1. Well, I don't know, because 1 times anything is that thing. If I only had 5, watch. Say that again? Yeah. Like, okay, because like if I didn't have the plus 1, if it was like that, it would just give me half of the question. So I need the plus 1 to get the rest of it. Yeah. Okay, so common factor, tried that one.
B is a common factor.
So you don't really have to be able to tell that today. But first of all, when I look at it, I see that there's common factor stuff in there. If there's ever a common factor in a question, you have to do that. But we'll talk more about that later. And also, it's not factor by grouping because all the factor by grouping questions we had 4 terms. So you can't do factor by grouping on that. It's only got 3 terms. But that's not something you need to worry too much about today.
So the term is just a number by itself.
A term is like a product. So a bunch of things multiplied together. So like 16 and x squared and y cubed is a term because they're all multiplied together.
Which is 1 be a term.
Yeah, 1 on its own is a term. Yeah. Okay, what's common between 16, 20, and 40? 2 goes into all of them, but is there something bigger? 4? Anything bigger than that? What about 8? 8 goes into 16, 8 goes into 40, but it doesn't go into 20. 5 doesn't go into 16, sorry. Yeah, 4. Very good. What about my x's? Liam, what do you think? X squared? And then y to the 1? Nice. And what's left? 16 divided by 4 is 4. X's are gone, y squared. 20 divided by 4 is 5. X's are gone, y. Negative 40 divided by 4 is negative 10. X squared, and the y's are gone. Okay, one more. Try this one on your own again. This is another factor by grouping question. It's got 4 terms, factor by grouping. Looks like you might want to rearrange it, but you don't actually have to. You can just do it like that. So give it a try. So common factor, the first 2. What do you get? You should get 2x. Riley?
How do you get 2x because 2 doesn't go into 5?
I'm only factoring the first 2.
Oh, okay.
Factor by grouping is how that works, right? It's different. If I tried to common factor all 4 of those, I think there's nothing in common, is there? Yeah. Yep. That's okay. Okay, so what's left? 2ax plus b. So I should, when I factor the next part, 2ax plus b, right? Should work out that way. What's common between the second 2? It looks like 5 and looks like a. There's an a there and an a squared. There's not an x in both. There's not a b in both. But there's at least one a in both. There's 5 in both. And when I divide it out, I get 2ax plus b. 2ax plus b, 2x plus 5a. A little bit strange. Give it a try.
Can there be like a question that we can use any of them with common factor?
Yeah, for sure. But there won't really be today. But down the road, yes, that's something we're going to look at for sure. Good question. Okay. See how it's broken up into common factoring questions and factor by grouping questions. So start with the common factoring questions. There they are. Give those a try.